Hello, welcome to Highway Engineering. In this lecture, we're going to go ahead and review what we did last week in class, Chapter 3. And I'm going to talk about the following, which I'm going to put on a board right now. There it is. We're going to talk about maximum gross weight of any group of axle. Ashton came up with the formula for bridge for weight in axle. So any consecutive axle, and we're going to use this formula. And then we're going to go ahead and talk about the safe stop side distance, SSD. And then we're going to go ahead and do a problem on dynamic characteristic of the vehicle, which is a power requirement. When a vehicle is in motion, what kind of forces acting on a vehicle, like the air resistant, curve resistant, grade resistant, rolling resistant. And then we can calculate the power requirement. And finally, we're going to go ahead and we'll talk about the high-speed horizontal curve and how we're going to calculate the radius. All right, let's look at the first problem, which is right there. Find out the maximum allowable overall gross vehicle of a W62 design vehicle. Now we can do this problem. If you take a look at the picture on the screen, and the L that we're looking for is the distance between consecutive axle. So if you look at it, it could be between the front tire and a second tire, or between the second tire and the last tire, or we can go ahead and say between a front tire and the last tire and get the distance and find the number of axle and calculate that. The formula for it is right here, and so this will become for, let's do the distance between the tandem axle, which is 41 feet. It's going to be 500. So W equal 500 times our L, look at the picture, is 41 feet, okay? And now the axle is 1, 2, 3, 4. That's 4 axle, and divide that by 4 minus 1 plus 12 times 4 and plus 36. Okay. Plus 12. Times 500, check my calculation, see if I got that right. 69,333. 69,333. So we're going to say 69,500. You're going to go to the nearest 500. So that was the distance between the two tandem axle. So now let's find out what is the requirement, road requirement, what we're going to find for the load between front axle and the rear axle, which is the L comes out to 69 feet. No, I'm wrong. 62.5. Okay, 62.5. So W equal 500 times 62.5. The axle are 5. Now you have to count all the axle, front one and the back 4 makes it 5. Then you have 5 minus 1 plus 12 times 5 and plus 36. Let's see what we're going to get for that one. $87.06. Okay. 86,000. That's how that? No, 87,000. 87,000 pounds and a change, so let's stay with that. That's it. Nothing to it. All you gotta do is plug and play. Okay? Let's do the next problem. I'm gonna go over onto the other side. And the next problem is gonna be, I'm gonna put it on a board here. Okay, we're going to talk about stop side distance. So the problem is the design speed of a multi-lane highway is 70 miles per hour. Find out first the minimum stopping side distance, that should provide for a level roadway? And then second, what's the minimum stop inside distance if the grade is 7%? So now let's look at the PowerPoint that we had that I put out. Vehicle, okay, right here. I put the PowerPoint on Blackboard, and if you don't have it, let me know. I'm sure I can email it to you. So now we have, right here, we have 3 different formula. You see what I had in a PowerPoint. Go to the lower left one. That's the easiest one to use, which is S is equal 1.47 V times 2.5 plus V squared divided by 30 times 3.35 plus or minus G. Now, S is a stop inside distance, and then V is obviously speed, and the grade is the grade of the road. Okay, now look at the problem. The problem says, let's look at the problem again. I lost the problem. There we go. 70 miles an hour. Okay, so we're going to go 70 miles an hour and 7%. So one thing about the problem is V equals 70 miles an hour, and then the grade for 2 conditions. A, when grade is equal 0 on a level ground, and B, when grade is equal 7%, but it didn't say which way. So it could be down or up. We're going to do both of them. Now, okay, take a look at the formula. I got it right here. I wrote it down. See, so it's become S is equal 1.47 multiplied by the speed V, which was 70 miles per hour, and then times 2.5. 2.5 is a reaction distance it takes for the driver to react. Then plus V squared, which is 70 squared, and that's 4,900 divided by 30 times 0.348 plus or minus 0. All right, I've already calculated it this time. I came up with 726. Again, double check my calculation. I could be wrong. So on the level ground, that's a safe stopping distance. Now the B asking for what is if we go 7%, add a 7% grade to it. So S is equal 1.47 times 70 times 2.5 plus 70 squared divided by 30 times 0.348 plus or minus 7% is 0.07, right? So when it says 7%, 7 divided by 100 makes it 0.07. And I get 2 answers, right? So S going uphill and S going downhill, it's going to be 2 different answers. See what I have. Check my calculation. I could be wrong. 646. And then going downhill, it's going to be 845. You notice something here. On the level ground is 725 feet. But if you go uphill, that distance shortened because of the grade resistance. And if you go downhill, increases. All right. So we're going to proceed to the next question. Don't go anyway. It takes me a few minutes to erase this. Okay, the next one we're going to talk about, the question is, it's on the board. It says, find out the horsepower developed by a passenger car traveling at a speed of 50 miles per hour. And upgrade and a grade, they're going up 5%. with a smooth pavement. The weight of the car is 3,500 pounds. So it probably like a big vehicle, like SUV maybe, and or a pickup truck. And then the gross cross-sectional area of the car is about 40 feet. All right. One of the things is, if you look at on the PowerPoint, you can see the, I'm put on a board right now, right there, the air resistance. First, we're going to calculate the air resistance. So the air resistance, if you drive in a vehicle, whether on a flat ground or downhill or uphill, it's just like when you're on a bicycle. You can feel the wind and it slows you down. It's the same way with the vehicle. So there's a wind that slows the vehicle down, and how much this force the wind create on a vehicle, and this is the formula we use. And that's equal to RA equal 0.5 times 2.5 times P, and P is the density of the air, which is a 0.076 pound per cubic foot at sea level. And then you have CD, which is the, it's different for a vehicle, and for a car is about 0.4. And then you have the cross-sectional area of the front of the vehicle. That's why some vehicles have the aerodynamic design so they can go better, like a sport vehicle. But something like SUV, pickup truck, it captures the air a lot, air slows it down. And then you have the speed squared divided by the acceleration of gravity, which is 32.2 feet per second square in English system. So that's let's get this one then, and then we go use a different color here. So RA is equal, is it 5 or 0.5? 0.5. 0.5 times 2.15 times P, which became 0.076, and times 0.4. Then we have times 40, which is the cross-sectional area of the vehicle, front end, and times the speed, 50 squared. And then we divide the whole thing by G, which is 32.2. And I already have calculated that. Check my calculation. I came up with 102 pounds. Okay. The next thing we have is we're going to calculate the rolling resistance. The see it on the screen. So the rolling resistance comes out to R equal Cn plus 2.15 CW Cn times U squared times the weight of the vehicle. And CW is a constant, which is a 0.012 per passenger car. And CW is a constant, typically is 0.065 times 10 by negative 6 seconds squared per feet squared for passenger vehicle. So RR comes out to .012 plus 2.15 and time 0.65 by negative 10 by power negative 6. That's what I meant anyway. Time, then the formula says time V squared, which is a 50 squared in this case, and then multiplied by the weight of the vehicle is 3,500 pounds. And that gave me 54 pound, 0.2. See if you got the same thing, double check my calculation. So now we got that. The next thing we're going to find is the grade resistance. And the grade resistance is, let's call that RG, is basically W times G, which is weight of the vehicle times the grade. And I got 3,500 pound times the grade was what? The grade was 5%. Okay, so 0.05. And that gave me 175 pounds. All right, so we got the air resistance, the rolling resistance, the grade resistance, and I think the next one is the curve resistance, but here there was the road, they didn't give any information on the curve, so it must be on a straight, it's on a straight road, so we don't need to calculate the curve. So we're gonna go ahead, calculate the power right away. And if you look at on the screen, the power is 1.47 summing all the resistant forces and multiply by the speed. So P is equal 1.47 multiplied by all these combined, which will be 102.3 plus 54.2 plus 175. Then what? Then divide by, no, time the speed, which was 50. Right. Divide the whole thing by 550. Okay. I don't think I calculated that. 102 plus 4 plus 175. Divided by 550. It looks low. 44.5 horsepower. Double check that number. It looks low. So this is how you find the power requirement for that question. Okay, let's move on to the next one. The next question was, I'm going to put on a board right now. Okay, come on, computer, cooperate. There it is. It says that the existing posted speed limit on a section of highway is 55 miles an hour. And studies have shown that the current 85% speed is 65 miles an hour. So now they want to increase the speed limit to 65 miles an hour, and then want to know if the how much we have to increase the radius of the curve. And assuming that the super elevation rate is 0.08 on an existing curve. One thing we want to do first, I will take a look at the screen here, see if I can find it. Right there, okay. So R is equal S squared divided by 15 times E plus F, and E is a super elevation of the highway, and then your F is a coefficient of the side friction, and we can find it from that table. All right, the problem says S is 55 miles an hour, but if we look at the table down there, we don't have 55 miles an hour. We got 50 and 60, so we got to do a linear interpolation between both of them. In this case, it's very easy. You got 14 and 12, therefore we can say, okay, it's 13. So now we go ahead, we say R is equal, and S squared, which is the speed, it comes out to 55 miles squared. Divide that by 15, multiply by E, and they said E was 0.08, and plus F. Again, look at the chart. We're going 55 miles an hour. 50 is 0.14, 60 is 0.12, therefore 55, it's got to be 0.13. 0.13. And it comes out to 960 feet. This time I calculated it. All right. So that's for 55 miles an hour. Let's do it for 65. Same formula, same thing. The only thing that's going to change is this F constant right here. So that's R55. Let's do R65. And that's going to be 65 squared. And divided by 15 times 0.08 plus. Now if you look at the charge, we got 60 is 0.12, 70 is 0.1, so 65 is 0.11. Okay. I end up with 1482. Okay, so now did you want to increase the radius from 960 to 482? Then you got to increase it by 500, isn't it? $522. Great. That's it.